T Coronae Borealis, also known as the Blaze Star, is getting ready to put on a spectacular show in the night sky. This rare nova eruption, caused by the interaction between a white dwarf and its red giant companion, has astronomers and stargazers excited. With a history of dramatic eruptions and recent signs of activity, T CrB is giving us a chance to learn more about how stars work. Scientists thought the eruption might happen by September, but months later, the star is still building up to its big moment. So, what's causing the delay, and why is this event so important? In this video, we'll look at this nova's history, the latest discoveries, and the challenges of predicting when this incredible event will happen. The first recorded eruption of T CrB in 1866 shocked the scientific world. Back then, the star suddenly brightened from a faint 10th magnitude to an astonishing 2nd magnitude, briefly matching the brightness of prominent stars like Polaris. This unexpected new star sparked fascination, though astronomers of the time had limited tools to study its origins. Still, it marked a major milestone, introducing the concept of novae as dramatic explosions on white dwarfs. 80 years later, in 1946, this nova erupted again, reaching a slightly dimmer 3rd magnitude. By then, advances in astronomy allowed for more detailed observations, revealing that the white dwarf's repeated explosions were fueled by material siphoned from its red giant companion. The discovery of a potential 80-year cycle emerged from this comparison, positioning T CrB as a key target for predicting future nova events. Historical records suggest the nova's eruptions extend even further back. Researchers have unearthed possible mentions of similar phenomena in 1787 and as far back as 1217, piecing together a centuries-long timeline. While less precise than modern observations, these accounts add depth to our understanding of the system's behavior, underscoring its long-term significance as a natural laboratory for stellar evolution. What sets T CrB apart is its human-scale predictability. Unlike other novae that erupt unpredictably over millennia, it operates on a cycle short enough to observe over generations. The anticipation surrounding the nova's next eruption has intensified over the past decade, thanks to significant new observations. Elizabeth Hayes, an astrophysicist monitoring the system with NASA's Fermi Gamma Ray Space Telescope, captures the excitement perfectly. We know it has to happen. We just can't pin it down to the month. Since 2015, T CrB has exhibited behaviors reminiscent of its pre-1946 eruption. The star's brightening episodes closely mirrored those observed 8 years before its last outburst, suggesting an accelerated timeline. Originally predicted to erupt in 2026, these observations prompted astronomers to adjust their expectations to as early as 2023. Adding to the intrigue, the system entered a dimming phase in March 2023, a pattern similar to what was seen before the 1946 eruption. This pre-eruption dip could signal ongoing instability as the white dwarf nears the critical mass required for a nova. Unlike the past, modern astronomers have a wealth of tools to monitor T CrB. Instruments like NASA's James Webb Space Telescope and Fermi Gamma Ray Space Telescope are capturing data across multiple wavelengths, something that was impossible during its 1866 and 1946 eruptions. Gamma rays, X-rays, optical, and radio signals are all being collected, providing a comprehensive picture of the system's activity before, during, and after the nova. This time is really the most important, Hayes explains. We're getting the best data set we've ever had on what a nova looks like before it goes off. This continuous observation allows researchers to refine their understanding of mass transfer dynamics, the conditions leading to thermonuclear ignition, and the aftermath of the explosion. While T CrB 80-year cycle offers a rough guideline, the precise timing of its eruptions is influenced by a range of unpredictable factors. Chief among these is the variability in material transfer from the red giant to the white dwarf. The red giant's mass loss rate fluctuates due to internal changes, magnetic activity, and tidal forces within the binary system. These fluctuations determine how quickly the white dwarf accumulates the critical mass needed for a nova. Adding to the complexity is the tight orbital separation of the two stars, just 0.5 astronomical units, half the distance between Earth and the Sun. This proximity creates intense gravitational interactions, shaping the flow of material and the stability of the accretion disk around the white dwarf. The accretion disk itself is prone to instabilities, which can either accelerate or delay the nova process. The lack of multi-wavelength data from past eruptions presents another challenge. In 1866 and 1946, observations were limited to the optical spectrum, leaving critical gaps in our understanding of the system's pre-eruption state. Now, modern telescopes aim to fill those gaps by capturing data across the electromagnetic spectrum. This comprehensive approach could revolutionize our knowledge of recurrent novae and their role in stellar evolution. One of the most exciting aspects of this effort is the opportunity to witness a nova ignition in real time. Observing the exact moment when the white dwarf's surface ignites will provide unprecedented insights into the physics of thermonuclear explosions. These findings could also shed light on the broader role of novae in enriching the galaxy with heavy elements like carbon and oxygen. As astronomers grapple with the complexities of T CrB, the anticipation only adds to its allure. The challenges of predicting its next eruption underscore the intricate dynamics of binary systems, but they also highlight the remarkable progress made in the field of astronomy. Thank you for joining us on this journey through the fascinating story of T Coronae Borealis. The blaze star's next eruption is more than a celestial spectacle. It's a chance to unlock new secrets of the universe and deepen our understanding of the stars. Stay tuned and keep watching the night sky. You could be witnessing history in the making.